All right, everybody, let's take a look at a couple of situations that are three-dimensional in the sense that it's a three-dimensional force vector and a three-dimensional moment arm. All right. So we've got some pipes here coming up out of the ground or attached somewhere, and two forces that are acting on them. And our job is to find the total force and the total moment. All right. And the moment needs to be around the origin. So to find the total force, we just take the two forces that were given, of course, and we're just going to add those guys up. Here we go. So we're going to get that. Our resultant force minus 300, 150, and then minus 250. Just like that. Okay, no big deal there. No big deal there. Now let's think about the moments. So in order to do the moments, we're going to have a moment arm. And so what we can do is we can set up our moment arm here for this guy. Okay, and so maybe we'll call that R1, and then you can know that M1 is just going to be that R1 crossed with F1. Okay. And so let me put down here what R1 is for you. Okay. So in terms of X, we're going to go backwards 1.5. Along Y, we're going forward 2. And we're going up 1 in Z. Okay. So just take that cross product in. That's going to pan out for you. Then we're going to need a moment arm for our force F2. And that moment is just going to be R2 crossed with F2. All right. And R2 is actually really similar, except we don't have an X component on R2. Then whatever you get for those moments, you're just going to add those up. Okay. And that's going to get your resultant moment. Okay. Just like that, piece of cake. Now let's look at one more that's three-dimensional, because I don't want it to bother you here. Here's another pipe assembly situation, and we've got F1 is straight backwards in Y. So let me go ahead and write that down. So we've got an F1 0 minus 100 0, and then looks like F2, it's a 200. It's on a 3, 4, 5 triangle. And so looks like we'll have, it's going back 4/5 in X, and it's going 0 in Y, but down 3/5 in Z. So this one's going to be 120. Just like that. So you can get the total force out of that thing. Okay, and then each one of those is going to create a moment. Okay, and so set up your moment arm for each one of those and end up getting an M1 vector, end up getting an M2 vector. Okay, so you can use an R1 like this and use an R2 out here like that. But what I wanted to point out is, what do you do with this guy right here? So like we saw before, that's an additional moment. So we have two forces. Each of those provides a moment, plus we have a third moment this time. And it calls it M sub C. And all we really need to do is realize that we can say that M sub C is, and see, it's right in the opposite direction of X. So we're just going to write minus 75, 0, 0. Okay. And then all you got to do is add up your moments, and that'll give you your total moment, and that'll come out really nice for you. Okay. That's it. Pretty straightforward.